is another class of theories which says, no, 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 we're not going to tweak the equations of motion. The Schrödinger equation, which is the equation you find in the standard algorithm, is always going to give an exact description of the evolution of the wave function. What we're going to do is deny this other quantum mechanical principle that the wave function itself is always a complete description of the physical system. Okay? We're going to say that, for example, in the case where you have a particle wave function which has a bump at A and also has a bump at B, there may nevertheless be a fact of the matter about where the particle is, okay? Because the wave function by itself is not a complete description of the physical situation. There may be some other variable, call it X, okay? Where, you know, the X is over the left bump but not over the right bump, and that means that the particle really is at position A, okay? Now, we'd have to know how these X's work, how they evolve in time, what their dynamical equations of motion are, so on and so forth. But anyway, this general strategy for solving the measurement problem is referred to usually as a hidden variable strategy, although hidden is a very bad word. I would call it an additional variable strategy.
Why do you not like hidden?
Because in fact, the claim of these kinds of theories is when you go and look for this particle, okay, it's this X that you see, okay? It's the opposite of hidden. Okay, it's this X that you see, not the wave function itself. Okay, good. So a good description of them would be extra variable theories or additional variable theories. Theories that deny that the wave function is the complete description of the world. So like I say, in accord with this aphorism of Bell's, one obvious way to try to fix the algorithm is to deny that the dynamical laws that you find in the algorithm are correct, okay? And try to tweak those dynamical laws so that in cases of measurement, you do suddenly get rid of one of the bumps and hang on to only one. The other obvious way to try to solve it is not to fiddle with the dynamical laws, but to fiddle with the way the world is described at any given instant, to deny that the wave function is a complete description of the physical situation of the world at any given instant. We now have beautiful, although preliminary, non-relativistic, so on and so forth, but beautifully worked out versions of each of this kind of theory.